sorry this has taken so long to get up, this firing video. My excuse is I have a 6-week-old baby at home, so anyone with babies will understand. Anyway, to fire this homemade metal clay, you have to get it completely ready for firing by drying it out. I do that in a toaster oven I bought at a thrift store for $5. I put it on one of these little grates. They're pretty readily available at jewelry supply places like Cool Tools. So I put them on here. I'd have several pieces on here. Put this in the toaster oven. Go right under boiling point, so maybe 200 degrees, 190 degrees. It'll get it really warm, get all the water out of it, but it won't boil the water. And if you boil the water, it'll crack, or it can even make little bubbles in your piece. So I do that for maybe 30 minutes to an hour. I'm always surprised at how long it takes to get these totally dry, even these fairly thin pieces. So once it's completely dry, cleaned up, I'd put a hole in it, clean up the outside. I would take this and I'd put it in my kiln. Now, a quick note about kilns. One, you can't really torch fire this stuff. I've heard from people that do copper clay that you can do it with really thin pieces, and you can torch fire and it'll work like it does with silver clay. I really haven't had any experience in that, and it's really not designed for that. And I don't really think it works that well. So don't buy all the stuff and then think you're going to torch fire it without a real jewelry kiln, because you really need a kiln like this. This kiln for ceramics that everything's sitting on is a possible way of doing it, and I have successfully fired metal clay in these kilns. The trick is regulating the temperature, because you can't, if you don't know exactly what temperature you're dealing with, you can go either too hot, which has generally been what I've done, or not hot enough for long enough at a consistent temperature, and you'll end up with cracked pieces or pieces with bubbles in it. I wouldn't even try to do it with bronze. Bronze is much pickier because of the zinc content. So with copper, you can pull it off because copper is much more forgiving. But you'd have to try to regulate the temperature somehow. One way of doing it is having a switch that you can turn up and down to make the kind of a rheostat. It's still kind of iffy, but if this is all you have and you only want to do copper pieces, you might be able to pull it off, but no guarantees. So this is the kiln that I would recommend, or at least a kiln like this, where you can program the temperature, you can hold temperatures for a longer period of time. So this Paragon kiln, you can find these pretty much anywhere in the jewelry world. They're used for enameling as well, and I've used them for small ceramic pieces. But next, we take our piece and we'll put it in the kiln. You can really crowd it in pretty well at this point. You could put several of these. I usually put at least 2 covered in pieces. They don't really have to be spaced out. I wouldn't have them touching, but that probably wouldn't even matter. So close it out, make sure it's all the way closed, make sure your top is off. And then I have this preset to do 2 different phases in firing. The first phase removes the methyl cellulose by burning it off, and then the piece will be black after that. The second phase you do in activated carbon, and that's what actually brings the pieces together and sinters them into effectively a piece of metal. So program it at a rate of 1,000 degrees per hour Fahrenheit, and then the last piece was going up to 1,000 degrees. So I don't want it to get any hotter than 1,000 degrees, and then I hold it there once it gets to 1,000 degrees for 30 minutes, and then it'll turn off and cool. As it does that, when it gets to about 700 or 800 degrees, it's going to start to burn. It's going to make a smell in your lab or your basement. If you have windows, probably not a bad idea to open them. You know, it worries me a little bit with these kind of things. I do it in my house, and I've never had a problem. I've never had my carbon monoxide sensors go off, and I have them around here. But it worries me when I'm burning things inside that I could produce carbon monoxide. Granted, this is a very small amount of actual stuff that is burning, but still, it can be a concern. So I would have a carbon monoxide sensor handy, or set up somewhere in the lab, or have a window I could open or something. So hold it there for 30 minutes, It'll all burn off. You'll even see a little wisps of smoke coming out of here, and that's why I like to leave it open. Once it's done, let it cool a little bit. You can open it up a little bit, kind of give it a chance to cool. You don't want it to like cool super quickly, but you can let it cool fairly quickly by leaving the door open like this. Once it gets down to 200 or 300 degrees, obviously it's still painful to touch, so you put a glove on. Like the heat will radiate out of here. Safety glasses probably are a decent idea. This is not hot right now, but you take it out, and then you've got your activated carbon ready. This is coconut shell carbon, and you put about an inch, well no, about a half inch to a, oh, there's another piece. So about a half inch of this stuff on the bottom. This will be totally black, like I said. You put it in there, and you'll take a little more carbon, cover it up, maybe another half inch, and then kind of spread it around. You'll have several pieces in there probably. The firing vessel, note about that, you probably want about as big as it'll fit. And then I put it up on little stilts. You can buy these stilts at ceramic suppliers. Anywhere you got your kiln probably would have them too. This is fairly cold, even though the pieces inside are hot. You can do it with your hand. This is an old pot, and you can see it fits pretty well. I just got lucky. My sister-in-law gave me this. But you could use stainless steel, little bowls, whatever works. I think it's good to have it a little bit elevated so the heat can kind of circulate around it. Some people put a lid on it. I've never put a lid on it, so I don't know if that's going to make a difference or not. You would think a lid would reduce the amount of oxygen that gets in and therefore would save some carbon, but I generally don't do it with a lid, and I'm pretty successful. So anyway, close this up. For the second phase of firing, it takes a little bit longer. And I'm going to pretend that this is bronze. This is actually copper. You can fire copper like bronze, but you can't fire bronze like copper. Copper can be fired up to about 1700 degrees for a couple hours, 2.5 hours at full ramp. Bronze is more like 1545 degrees Fahrenheit. If you go too high, you'll get bubbles in your bronze. It'll be totally destroyed. If you go too low, the bronze won't sinter at all. People sometimes will mix copper and bronze in the same piece, like in a swirl pattern, or half the piece will be bronze, half the piece will be copper. It makes some contrast. It doesn't make a ton of contrast, in my opinion, but you can do it. So I have my preset 2. So program 2, rate full, Fahrenheit's 1550, 1545, 1550. That's what works for this kiln. You're going to have to experiment a little bit with your kilns because each kiln behaves a little differently. And then you hold it for 2 hours, 30 minutes. Rate 2, nothing. Start, and then it'll heat up. And once it gets up to temperature, it'll hold that for 2.5 hours. And then I usually let it cool overnight. It'll get down to 400 or 500 degrees at that point. But I'll open it up at the end, kind of let it, if I'm impatient, let it cool a little more, kind of open it up. And then I have some pliers that I will take it out of the kiln with. I think I have them upstairs actually. But anyway, you take it out of the kiln. Let's just pretend I have some little grippy pliers. Just be careful. This is super hot at this point. Don't put it on anything that's going to burn or be damaged. A piece of wood probably is not a good idea. So now I've got my piece, and I've got, let's see, okay, boom. I've got a piece of bronze here that's been fired but hasn't been polished. The first test I do, you can quench them in water. If they're not completely sintered, that will usually destroy them, so I don't usually do that because you can try again by firing again sometimes. But since this is the first test to see if it works is to see if it makes a metallic sound. If it's kind of thud or if it's not really tingy, it probably didn't work, and you probably should try firing again, maybe at a little higher temperature. So a note about the activated carbon: you can only use it 2 or 3 times, and then you've got to start a new batch. In between firings, you take 2 bowls and you kind of do this thing out in the wind outside, and you can get the wind to kind of blow away some of the ash. If you use it more than 2 or 3 times, it really doesn't absorb the oxygen as well, and you end up with some with pieces that just don't work. The carbon's not super expensive, and since you can use it several times, it's not too bad. So, okay, that is firing. Let me know how it works. I've had pretty good success. Here's a pair of earrings that show bronze once it's finished. So you can see that you can get pretty good detail, and you can make pieces that look kind of nice. So thanks for watching, and sorry again for taking so long getting this up.